Okay, so let's do another example. So if we look at this alternating series, we've got this b term here. Okay, and so we're going to focus on the b term, and again we want to see how it's behaving. So if we look at b n plus 1, which I'm just doing it a little bit differently. So b n plus 1 equals what? It's going to be n plus 1 over 2 to the n plus 1, right? And we're also going to look at n over the 2n, which equals b sub n. And we want to see that those terms, b sub n plus 1 is less than b sub n for all n greater than or equal to 1. Okay, now, it's easy to see that this is growing faster than this term. So the bottom term is growing faster than the top term. This is growing linearly, this is growing exponentially. Okay, so it's easy to see that the limit of this thing is going to 0, and it is also for all n greater than or equal to 1 that the terms are going to be less than the previous term. Okay, since these are all positive, right? So for example, if I have 1, so n equals 1 would be just 1/2, and then for n equals 2 you have 2/4, 3/8, 4/16, right? So and so on, right? 5/32. Okay. So we can see that for every term, subsequent term is always going to be less than or equal to, because this one is the same as 1/2, right? Yeah, I'm just going to keep it back. So this is the same as 1/2. Okay. This is 1/4. And so on. Okay, so we can see that this is a decreasing terms. So it's decreasing in terms. Also, again, if we take the limit as n approaches infinity of n over 2 to the n. That this is going to 0. And so since this is a decreasing function, or actually not decreasing function, but it's decreasing terms, the terms are decreasing as n goes to infinity, okay? And the limit is going to 0, we can conclude by the alternating series test that the series converges. That's it. Have a great day.